let us see this problem. A small mass m is attached to the massless string whose other end is fixed at P as shown in the figure. Now, this is the point P and this is the mass small m. The mass is undergoing circular motion in the xy plane with center at O. This is the center O and constant angular speed omega. This is rotating with omega. If the angular momentum of the system calculated about O and P are denoted by L0 and LP respectively, then which of the following is correct? Right. Now we have to see over here that L0 over here is in vector form, vector, and LP is also a vector quantity. It is also given with an arrow, right? So what will be L0? This is a massless string. This string is massless. So if we talk about angular momentum about O, what will happen? This mass is rotating with an angular velocity of omega about this point O. L0 of any particle, right, of any particle about any point is given by mvr, right, and v will be equal to r into omega. So this will be equal to m r square into omega. This will be L0, right, angular momentum about O of this particle m. Now since its velocity is in this direction, so if we take the cross product, L0 can also be written as m into v cross r, right. Now r at every point is perpendicular to v. In this direction we have v. Now so that means this will also be equals to mvr. So that means if we talk about at any point, this will be remaining constant because v is constant, or we can say that omega is constant, radius is constant, mass is constant. That means L0 does not vary with time. L0 is constant. Right. Now if I talk about angular momentum about point P, right, angular momentum of this mass m about P, what will be this? Again LP will be equal to m v cross r, where r will be this vector. Now since v cross r, that means the direction, we know that when we are cross multiplying two vectors, the resultant we get is perpendicular to both v and r, right. So that means it would be something in this direction, right, it would be in this direction. So the answer we will be getting, it should be the same, right. If the length is L, if the length of the string is L, so we'll be getting m into r omega into L, right. R is constant, L is constant, omega is constant, m is constant. But we over here see that the moment, the magnitude of LP is constant, right. But what about the direction? Right now it is at this point. If we talk about this point, B point, let us suppose, if we join this, now again at this point, at B point, LP should be perpendicular to both the velocity and R. Now velocity at this point should be in this direction, and this is the direction of R, so it should be perpendicular to both. That means in this direction, right, somewhere in this direction rather, right. So over here we see that the direction of LP is changing, right. So that means the vector LP is not constant, its direction is varying with time, right. So that means option C says L0 remains constant while LP varies with time. That means option C is correct.